In this video, we're going to use a trig substitution to evaluate this particular integral. We'll also probably need a standard u-substitution. So this has x squared, that would be your u squared minus the constant of the 3. It fits number 2 here. Got the square root of the variable squared minus the constant squared. And here we're going to use the substitution secant theta equal to u over a. We'll let u equal to a secant theta. In our case, it's just going to be x. So in that setup, the u will be the x. It's u squared minus a squared. A will be 2. The u will be x. So the idea then is to use those trig substitutions to transform this integral into the variable theta, evaluate it, and then use the triangle to get it back into the variable x. So the triangle we're going to use is right here. The angle theta. The opposite side is the square root of x squared minus 4. The x here is the u in the setup that we looked at. And then the a is 2. So this would be u squared minus a squared. And we go ahead and say secant, and we get 2 secant theta. And then take the differential there. The derivative of dx is equal to, and then the derivative of secant is secant theta, tangent theta, d theta. So this tells me that wherever I have an x in that integrand, I can replace it by secant theta. And wherever I have the dx, I can replace it by 2 secant theta, tangent theta, d theta. Now once we get this evaluated in terms of the angle theta, then we come back and use this triangle to put it back into the original variable. So here are my substitutions. Where I have a secant theta, I'm going to replace it by, where I have an x, I should say, I replace that by 2 secant theta. Where I have the dx, that's going to equal to 2 secant theta, tangent theta, and that's d theta. And then I'm going to need a representation for this radical. So it's x squared right here, and x is 2 secant theta, so that's going to be 4 secant theta. So where I have the x, I'm replacing it by 2 secant theta, and then I'm squaring that, so this could be 4 secant squared theta. Then minus 4. Then I'm going to factor out the 4 here, and that'll leave me with secant squared theta minus 1. Then I'm going to take the square root of 4, that'll be 2. And then I still have under the radical secant squared theta minus 1. And we know that 1 plus tangent squared theta equal to secant squared theta. So bringing the 1 over, this can be replaced by tangent squared. But I'm taking the square root of that, so this will be tangent theta. So again, in the integrand where I have this expression here, that'll be replaced by 2 tangent theta. Where I have an x, that'll be replaced by 2 secant theta. And where I have the dx, that will be replaced by 2 secant theta, tangent theta, d theta. And then simplify, and the integral we get should be one involving theta only. So right here then, set this up. This will be x cubed. And the x is going to be 2 secant theta. Right here, x to the third, and x replaced by 2 secant theta. And then the radical is replaced by 2 tangent of theta. And then the dx is replaced by 2 secant theta, tangent theta, that's d theta. So let's go through this. So you got 2 to the third here, that's an 8, and then 2 more, that's 16, and then times 2 more, that's 32. I'll put the 32 out here, and that's going to be the integral of, and then we have secant to the third, and then we have another secant over here, so this will be secant to the fourth theta, and then we have a tangent theta, d theta. And then we have a tangent here and a tangent over here, so this is going to be squared. Again, 2 to the third is 8, then 2 is 16, then 2 is 32. And then we have a tangent, an extra secant here, secant to the fourth, and a tangent times tangent, so we get this expression right here. Now everything is in terms of the angle theta. So this is where we're going to proceed the rest of the way, taking this. Okay, so we start right here then. So far then, what we've done is we've broken this integral here into this form. So this is equal to, and now we have a secant to the fourth, tangent to the second. And we want to break this. Again, I can put the 32 out in front here. It's constant. So this will be then, I'm going to break up the secant to the fourth into secant squared theta and secant squared theta. And then I've got a tangent of theta, d theta. So what I'm going to do here, I'm going to let u, I need a u substitution now. I'm going to let u equal to tangent of theta. So du, derivative of tangent, is secant squared theta. And this will be d theta. And then I'm going to replace this secant here. Secant by one of your trig identities is 1 plus tangent squared theta. And notice here I have secant squared, and this is theta. What I'm going to do now is I'm going to take this tangent theta and I'm going to multiply here. And the reason I'm doing it here is because I know, the reason I let u equal tangent of theta is we know that derivative of tangent is secant, so the object then is to eliminate some of these terms and get it down to something we can work with. So this is then going to give me 32, the integral of, so this tangent here, I'm going to multiply through here. So this is going to give me tangent of theta. And of course this was the square here. So when I multiply times this expression here, this is actually a squared, tangent squared theta. And then this is plus. And then tangent squared times tangent squared, that's tangent to the fourth theta. And then now, so this tangent squared has been multiplied out in here. So all I have here is the secant squared theta, but the secant squared theta, d theta, that's the du. And then we let u equal to tangent. So again, now let's convert. You can actually do the integral here, but just so you can see the substitution here, I've got 32, and then the tangent is u, and that's squared. The tangent theta here is u, and this is to the fourth, and then this is to u. And now it's just a simple integration here. So again, I'm going to leave 32 out here, and we integrate here with respect to u. So what we do again, basic power rule for integrals. Add 1 to this one, that's 3, and divide. So this will be u to the third over 3. Plus, same thing here, u to the fifth, add 1 to the 4 and divide, we get this, and then have your constant of integration. But this is u. So remember the original integral was in the variable x, so we have to go back. So let me continue the next step over here. So it's just going to be 32, and this is u to the third, but remember now we're going to try to go back to the original variable. So this u right here is tangent. So we go to the triangle. So the triangle was, this is supposed to be a right triangle here. So this was the square root of x squared minus 4. This was a 2 here. This was an x. Remember that the u is tangent. So we just go to the triangle and find the tangent of the angle theta right here. So that's the square root of x squared minus 4. over 2. And this is all in the numerator here. This is u to the third would be tangent. This is what we get to the third power here. And that's over 3. And this is plus, and again, u to the fifth, but u is tangent, so this is again going to be the square root of opposite over the adjacent, x squared minus 4 over 2. This is going to be to the fifth power over 5. So let's continue from here then. So we got here then, I'm going to multiply through by the 32 here. So again, this is going to be, can I cube this? Let me do it this way. Let me write it this way. X squared minus 4. That's to the 1/2 power. So when I'm cubing that, I multiply by 3. So I can write the square root of x squared minus 4. If I cube that, that's going to come out to the 3/2. And then 2 to the third is 8. 8 into 32, that'll be 4. Let me put it out here. And then I have that 3 over here. And for this one here, or 2 to the fifth, if I take this expression here to the fifth power, again the radical is square root, that's to the 1/2, so to the fifth power that'll be 5/2. And then 2 to the fifth is 32, and then I multiply by this 32 here, that's going to cancel. So this will just give me x squared minus 4 here, and I'll still have that 5 down here plus the constant of integration. Now this is actually your answer. This right here, you could actually give this as your answer. But this again a situation where if you're working these problems out from your textbook and you got answers to these, this is what could happen. So I'm going to rewrite this so it looks like the answer in the book. I'm using a textbook for the course that I teach. So instead of leaving it like that, which you can leave it in this form, that's the answer. I'm going to factor out an x squared minus 4 to the 3/2 power. So I'm going to take my next step will come up here, so I don't have to scroll down, because this won't stay stationary here. So this will be x squared minus 4 to the 3/2. So I'm taking this out, x squared minus 4 to the 3/2, so that's just going to leave me with a 4 there over 3. And then on this is a plus here. Then if I take out an x squared minus 4 to the 3/2 power, the second term there, this would leave me with x squared minus 4 to the 1 power. This times this will give me this, and this is over 5. And of course I have the constant of integration. Again, this is your answer. You can accept this as an answer, but this is just, as I've mentioned before, sometimes you're working problems from the back of your textbook. They have the answers to the exercises, and you work it out, and you spend a lot of time on it, and it doesn't match it. So this is kind of the stuff that they do. So here I'm just going to find the common denominator here. So I'm going to multiply this by 5 here, this by 5, this by 3, and the top by 3 here. So I'll get x squared minus 4 to the 3/2 power, and then this will give me 20 over 15, multiplying by 3 here, and then in the second expression I get 3 x squared minus 12 over 15. So then I can combine these 20 and minus 12. That'll combine to, let me say, 20 over 15 plus this expression here. I got the same denominator, so I could add the 20 and the minus 12 plus 8. And then I'm going to factor out the 1 over 15. So the answer in the back, at least about our textbook, looks like this: 1 over 15. And this is x squared minus 4. 3 has power. And this inside then, after I've taken out that 15, this can be written as 3x squared plus 8. Again, remember I factored out the 1 over 15. That's why I didn't have the denominator. So the answer in the back looks like this, at least in our textbook. But the answer that I gave you first, that will work too. Thanks for watching. We'll see you next time.